Welcome to lesson 5.5. Today we're going to be talking about solving two-step equations. Our learning objectives: being able to write two-step single variable equations from verbal models, being able to solve two-step variable equations. You will be able to identify properties used to solve multi-step equations, and being able to model and solve real-world problems using two-step equations. Here's our introductory problem. Make sure you read through that before moving on. So in the last two lessons, we worked on solving single variable equations. Here's one example: 3x equals 15. Now if you think about this equation, you only had to perform one operation to solve it. We used an inverse or opposite operation to solve it. Because this is a multiplication equation, we used division to solve for the unknown variable. We could say that we performed one step to solve this equation. This one step was to divide. We call an equation where one operation is needed to solve it for an unknown variable a one-step equation. So what happens when there is more than one operation needed to solve an equation? When this happens, we have two-step equations. A two-step equation has two operations in it. Let's look at a few examples of two-step equations. We've got 3x plus 5 equals 20, and x divided by 3 minus 2 equals 5. If you look at both of these equations, you will see that there are two operations present in each. The first equation has multiplication and addition. The second equation has division and subtraction. You will see other variations of two-step equations too, but this gives you an idea. Before we begin solving equations, let's look at how we can write a two-step equation from a verbal model. First, let's think about some of the words that mean addition, subtraction, multiplication, and division. Identifying these keywords is going to assist us when writing equations from verbal models. Remember that a verbal model uses words. So if we're doing addition, they're going to use words like sum, added, altogether, in all, plus, or and. For subtraction, difference, less than, more than, take away, subtract. Multiplication, product, times, groups of. Division, quotient, split up, or divided. So we're going to write an equation for this verbal sentence. 6 times a number plus 5 is 41. Okay, so if we have 6 times a number, we would say 6n. Plus 5, we're going to add 5, is means equals, and then 41. So the equation that would go with it is 6n plus 5 equals 41. Now we have 4 less than 2 times a number is equal to 8. Okay, so here we have the 2 times a number, so I'm going to put 2n right there. Then we've got 4 less than that. So 4 less means we're going to subtract 4. So 2n minus 4 is equal to, means equals, then the 8. So 4 less than 2 times a number is equal to 8 is 2n minus 4 equals 8. Our next example, a number divided by 2 plus 6 is equal to 14. A number divided by 2, so n divided by 2. Then we have plus 6, so n divided by 2 plus 6 is equal to, equals, and then 14. So a number divided by 2 plus 6 is equal to 14. For our equation, we would say n divided by 2 plus 6 equals 14. There is our answer. Go ahead and pause the video and write an equation for all three of these, and then hit play and see how you did. So for the first one, the product of 5 and a number plus 3 is 23. We should have gotten 5n plus 3 equals 23. For the second one, 6 times a number minus 4 is 32. We should have had 6n minus 4 equals 32. For the last one, a number, y divided by 3 plus 7 is 10. We would say y divided by 3 plus 7 equals 10. So now that we know how to write two-step single variable equations, it's time to learn how to solve them. When we solve the equation, we'll be looking for the value of the variable in the equation. Sometimes you'll be able to solve the two-step equation using mental math, particularly when the numbers are small and are all positive integers. You might be able to solve them in your head. This is the first method that we're going to look at. When we're solving equations that we can't use mental math, and we need to think of PEMDAS. Now you should remember PEMDAS as our order of operations. However, when we go to solving, we are going to actually use the reverse order for PEMDAS. And we're going to use addition or subtraction first, then go to multiplication and division. Okay, it'll be very rare that we're going to use exponents or parentheses here. Okay, so we're going to start with addition or subtraction, then move to multiplication and division. So if we have 3x plus 3 equals 9, okay, the first thing we want to do is undo any addition or subtraction problem. Okay, so right now we are adding 3. So to undo that, I need to subtract 3. And if I subtract 3 from the left, I have to subtract it from the right as well. So those will cancel out, leaving just 3x on the left. 9 minus 3 gives us 6 on the right. Now I have to undo the multiplication of 3 times x, and I do that by dividing by the 3. If I divide the left by 3, I have to divide the right by 3 as well. The 3's cancel out, leaving just x. 6 divided by 3 gives me 2. My answer is x equals 2. For our second example, 2 plus 3n equals 11. Again, I've got an addition here, so I need to undo that first, and I can do that by subtracting 2 from both sides. If I subtract 2 from the left, it'll cancel out with this 2, leaving 3n. If I subtract 2 from the right, 11 minus 2 gives me 9. Now I've got 3 times n equals 9. I have to undo this multiplication, and I can do that by division. So I'm going to divide by 3 on the left. I have to divide by 3 on the right as well. The 3's cancel out, leaving just n on the left. 9 divided by 3 gives me 3. So my answer is n equals 3. 2x minus 5 equals 11. So first thing I'm looking for is any addition or subtraction. I've got this subtraction right here, minus 5. I undo that first by adding 5. So I'm going to add 5 to both sides. The 5's cancel out on the left, leaving 2x. And on the right, 11 plus 5 equals 16. So I've got 2 times x equals 16. I have to undo this multiplication, and I can do that by dividing. So I'm going to divide by 2 on the left, and I have to do the same thing on the right. The 2's cancel out on the left, leaving just x. 16 divided by 2 on the right gives me 8. My answer is x equals 8. Now I have x divided by 5 minus 8 equals 17. Again, I'm undoing any addition or subtraction first. So I have to undo this minus 8, and I can do that by adding 8 to both sides. The 8's cancel out on the left, leaving x divided by 5. On the right, 17 plus 8 gives me 25. So now I've got x divided by 5 equals 25. I have to undo this division, and I can do that by multiplying by 5. And if I multiply the left by 5, I have to multiply the right by 5 as well. The 5's cancel out on the left, leaving just x. 25 times 5, if I type that into my calculator, I should get an answer of 125. So x equals 125. Go ahead and pause the video and solve all 3 of these on your own, and then hit play and see how you did. So for the first one, you should have added 8 to both sides first and then multiplied both sides by 4, and you get an answer of y is equal to 48. For the one in the middle, you should have subtracted 7 from both sides first, then divided both sides by 5, giving you an answer of x equals 5. For the last one, you should have subtracted 9 from both sides, then divided both sides by 3, giving you an answer of a equals 10. So now we're going to look at a couple of word problems. So a landscaper charges $35 for each landscaping job plus $20 for each hour worked. She charged $95 for one job. So we're going to write an equation to represent h, the number of hours that the landscaper worked on that $95 job. So h is our number of hours worked. If you'll notice, $20 is with the hours worked. So we're going to put 20 times h. Then they charged $35 for the job on its own, so we're going to add that onto the end. So we got 20h plus 35, and it gives us a total of the $95 that she charged total. So now we're going to have this equation here, 20h plus 35 equals 95, and we're going to solve it. So the first thing we should do, undo any addition or subtraction. Right now I have a plus 35, so I need to subtract 35. And if I subtract from the left, I have to subtract from the right as well, giving me 20h on the left is equal to 60 on the right. Now I've got to undo this multiplication of 20 times h, so I'm going to divide both sides by 20. Divide by 20, divide by 20. On the left, it cancels out, leaving just h. On the right, 60 divided by 20, if I type that in, I would get an answer of 3. She worked 3 hours on this landscaping job. Here's the ending to the introduction problem. Make sure to read through that before moving on. So to review, for two-step equations, make sure to do division or multiplication inverse operations before completing subtraction or addition. It is important to complete inverse operations on both sides of the equations. When doing the inverse operation of multiplication, be sure to do the reciprocal for fractions. Always check your answer by substituting the value of the variable into the original equation to make sure the statement is true. The inverse operation is the opposite operation. The addition property of equality states that as long as you add the same quantity from both sides of the equation will remain equal. The subtraction property of equality states that as long as you subtract the same quantity from both sides, the equation will remain equal. The division property of equality states that if both sides of the equation are divided by the same number, they will stay equal, and the multiplication property of equality states that if both sides of an equation are multiplied by the same number, they will stay equal.